Sugar cane, often referred to as green gold, is not only a source of sweets but also an important raw material in the renewable energy sector. According to the World Bank, global sugar cane production in 2021 was about 1.85 billion tons, which means we have about 185 million tons of bagasse produced each year. With this extremely huge amount, bagasse has become a raw material for bioenergy production, food packaging, paper. So how does this recycling process work? In today's video, we will take a comprehensive and detailed look at the process of recycling bagasse, a typical example of the circular economy. The journey begins in the vast sugarcane fields of Brazil. After 14 months of planting and tending, farmers harvest the sugarcane using advanced machinery that minimizes waste. The harvested stalks are transported to nearby factories, where the extraction process begins. The cane stalks, up to 6 meters tall, are chopped after harvesting. Large crushers crush the stalks, extracting the juice. This juice is processed into sugar or ethanol, leaving behind the bagasse. Conveyors carry the bagasse to storage areas, where it is prepared for further processing. Since there is still water inside, the bagasse must be dried to reduce the moisture content. This step is important to increase the calorific value and make recycling easier. Bagasse can be spread out in the open to dry in the sun or in modern factories. Large rotary mechanical dryers or fluidized bed dryers are used for faster and more uniform drying. After drying, the moisture content of the bagasse is reduced from about 50% to less than 10%, making it ideal for use as a raw material. After processing, bagasse is ready for recycling processes. Bagasse is mainly used as a biofuel to generate energy, powering sugar mills and feeding into the national grid. First, bagasse is fed into a high-efficiency boiler to burn to generate heat. The heat creates steam, which rotates a turbine to generate electricity. This electricity is reused for the recycling plant itself, and the excess electricity generated is fed into the national grid. Brazil, the world's largest sugar producer, uses Bagasse to generate 9% of the country's electricity. More than 400 sugar mills in Brazil have installed biomass boiler systems, providing about 20 terawatt-hours of energy per year, enough to power about 10 million homes. In addition to energy, bagasse is also a versatile raw material for the production of bioproducts, most commonly paper and cardboard. About 25% of bagasse is recycled into paper and cardboard. Bagasse fibers are cleaned and ground into pulp. The pulp is then pressed and dried to form environmentally friendly paper and cardboard products, serving as a sustainable alternative to wood-based materials. 1 ton of bagasse can produce about 150 to 200 kilograms of paper. Using bagasse to make paper helps reduce the felling of 20 million trees each year and reduce water consumption by about 30 to 40% compared to producing paper from wood. In addition, bagasse is also processed into pellets or mixed with other feed ingredients, providing a sustainable and cost-effective source of nutrition for livestock. First, bagasse is chopped and fermented to make it easier to digest. Then nutrients such as protein or trace minerals are added. Finally, the mixture is packaged and preserved for livestock feed. Fermented bagasse contains about 30 to 40% fiber, which helps improve livestock digestion and reduce livestock costs by 20 to 30% compared to traditional feed. Bagasse is also used to make eco-friendly biobricks or cement. First, the bagasse is crushed, then dried to reduce moisture. Then the bagasse fiber is mixed with cement or other bioadhesives to create a mixture. The mixture is poured into molds, compacted to shape and increase durability. The product is dried or fired to achieve the required hardness before use. As a result, panels or bricks made from bagasse are lightweight, well-insulated, and suitable for sustainable construction projects. In Thailand, a factory produces 5 million bagasse panels per year, reducing the consumption of 200,000 cubic meters of wood and saving about 15,000 tons of CO2 emissions. Bagasse recycling exemplifies the combination of innovation and sustainability. By converting agricultural waste into energy, valuable bioproducts, and chemicals, the process not only meets energy needs, but also sets the standard for environmentally friendly practices. This comprehensive process ensures that every ounce of sugarcane is used, leaving no waste behind. As we continue to seek sustainable solutions for the planet, Bagasse inspires us to tap into the full potential of renewable resources. Hello everyone, nowadays you can easily see ships with a tonnage of hundreds of thousands of tons moving at sea waiting for goods or oil to reach all over the world. But the thing that helps them stop is the main character in today's video. To stop these giant ships, people have to use ship anchors, which consist of two main parts, the anchor and the chain. Made of alloy steel with the main components of iron, carbon, silicon, manganese, they are added with molybdenum or chromium for durability and superior corrosion resistance. They can operate for 20 to 50 years if properly maintained. However, nothing lasts forever. After a period of tireless operation, these chains will be retired. So what will people do with them? Considering the composition and technical properties of these chains, they can be an invaluable resource for other uses. So they will be recycled to continue a new life cycle. In today's video, let's learn about the process of recycling these anchor chains. First, after being removed from old ships, these anchor chains are transported to a recycling plant. Because of their large volume, removing anchor chains is a complex process that requires a high level of skill and close coordination to ensure safety. At the ship-breaking yard, the process begins with securing the ship, collecting the chains, and lifting the anchors out of the water using a winch system. Workers then use chain cutters or link breakers to break up the chains, remove the connecting pins, and lower them to the ground using a crane. This is a local recycling plant where workers with rudimentary equipment use their skills to give them a new life. First, workers use oxyacetylene cutting machines to cut these links. The temperature generated by this cutting machine reaches 3,200 degrees Celsius, melting the steel, and the oxygen gas will blow strongly into the cutting area, helping to create a clean cut, making the steel material cut through without being deformed. However, the cutting process creates a large amount of smoke and sparks and requires high skills to operate safely. The links continue to be cut smaller until they are about 10 centimeters long. In countries such as Bangladesh, Pakistan, India, the ship recycling industry creates many jobs for people, but also brings many consequences due to unsafe working environments and rudimentary tools. Now our links are ready to start a new life. They are put into the furnace to heat up. The temperature of the furnace will reach about 800 to 1,000 degrees Celsius. When the steel is red hot, its crystal structure changes, making the iron more flexible and easy to deform under the influence of external forces. Therefore, it is more convenient for the recycling process. After the steel is red hot, it will be shaped. This is the step that combines strength and skill, ingenuity. The automatic hammer provides strong impact force to shape, while the worker skillfully changes the position of the steel bar to shape. Under the great impact force of the hammer, the steel bar flattens. The worker skillfully places a small steel bar to create an eyelet. The steel is continuously heated to ensure the temperature is suitable for the shaping process. Each time it is heated red hot, the steel bar is given a new shape. The wings of the pickaxe are created by beating two parts of the chain to the sides. One wing is made with a pointed tip, the other wing is made with a flat tip. The pickaxe is shaped many times to achieve the desired shape and size. Finally, after cooling, the pickaxe is painted with a protective paint and is ready for a new life. The ship's anchor chain is made of hard steel, which has good resistance to force and abrasion. This steel is highly durable, so the pickaxe is not only durable over time, but also resistant to environmental impacts. Anchor chains, after long journeys at sea, after completing their mission, are recycled. This is the beginning of a new, more sustainable life cycle, a typical example of the circular economy. Welcome back to the IronHand Tech channel. Today we're going to dive into the modern recycling process of plastic bags. First, let's explore the harmful impacts of plastic bags and why we need to promote recycling. Born in the early 1970s, plastic bags have brought us many conveniences. Thanks to their convenience, durability, water resistance, moisture resistance, and strong load-bearing capacity, plastic bags have been applied in many fields and industries. Today, plastic bags have become a global product, produced at a rate of 1 trillion bags per year. This means that each year, humans release about 1 trillion bags into the environment. Plastic bags are everywhere on Earth, even in the deepest parts of the ocean and the highest peaks of Mount Everest, posing a significant environmental challenge. It is estimated that it takes only 1 second to throw away a plastic bag, but it can take 500 to 1,000 years for it to decompose. Some types of plastic bags may never decompose if not exposed to direct sunlight. Plastic bags are extremely dangerous to human health. When burned, the smoke released into the environment contains toxic substances such as dioxin and furan, which are two types of poisonous gases that can cause poisoning, impaired immunity, birth defects in children, and even cancer. Even when plastic bags are used to store food, the risks they pose to health are enormous. When discarded into the environment, they alter the physical properties of the soil, clog drains, cause stagnation, and breed bacteria that cause diseases in humans and cause mass deaths of marine animals that ingest plastic bags. All of these reasons are more than enough for us to care about the issue of plastic bag recycling. Don't you agree? So let's explore the process of turning used plastic bags into new ones. As someone who is interested in recycling, surely you know that the first thing to do in this process is to collect plastic bags, right? That's right, plastic bags of recyclable type are collected from many different sources and concentrated in the recycling plant. And of course, this is an indispensable source of raw materials for this process. After plastic bags are classified by plastic type, they will be classified by color or not depending on the final product. There are recycling processes that need to sort bags by color to ensure the quality of the final product. Usually, transparent plastic bags are usually preferred for recycling. Printed plastic bags are often removed from recycling because the printed inks on the surface of the bags directly affect the recycling process and the quality of the recycled plastic beads. Next, they will be thoroughly cleaned, removing all dirt and impurities from the surface. After the impurities on the surface have been removed, the plastic bag will be put into a specialized crusher to grind into small pieces. This step will make the subsequent cleaning process easier and ensure that the plastic bag actually removes all impurities before being melted. As well as the PET plastic bottle recycling process, after co-minuting small pieces are passed through the cleaning tank. However, the crushed pieces of plastic bags are usually very light and almost completely float on the surface of the cleaning tank. So it is necessary to use water nozzles with strong pressure to spray continuously on the tank surface. Along with that are rotating shafts with many small teeth rotating in the same direction. They are both to assist in cleaning plastic pieces and to transfer clean plastic pieces to the drying process. Twisted spindles bring clean plastic pieces to the dryer. The usual dryer is the blower. We now have clean materials ready for fusing, extrusion, and recycled plastic pellets. Raw materials are put into the furnace along with additives to create chemical reactions in the furnace. Do you know what? Yes, as mentioned at the beginning of the video, plastic bags, when burned or melted, will create extremely toxic substances such as dioxin and furan, along with many other toxic gases, which will directly affect human health. With the old recycling process, workers who directly work in recycling, or people living near the recycling area, will have direct health effects. However, with modern technology closed and a process to treat exhaust gases before being released into the environment, this is no longer a concern. The additives will render the toxic substances harmless and have gas filters to prevent the remaining toxic substances from escaping from the kiln, and the chemical reaction process, again taking place in the kiln, renders the toxic gas harmless. It's amazing, isn't it? Let's go back to the recycling process. After being melted, we will obtain liquid plastic. The liquid plastic will be passed through the extruder to form long plastic fibers. The plastic fibers will be passed through the cooling tank to create solidity. And then these plastic fibers are passed through the cutter to form small plastic particles ready for the recycling process into new products. In today's process, let's see how new plastic bags created from these recycled plastic particles work. The plastic particles will be mixed with colorants if you want the new plastic bag to be colored, or you can make a transparent plastic bag without adding colorants. However, a few additional additives may be needed to increase the physical properties of the final product. These plastic particles are fused again, then they are fed into a blower to form a thin plastic film. Next, this film will be passed through a system of rollers with the following purposes: fixing the shape of the film, cooling, laminating, flat pressing, surface reinforcement, even printing if necessary, and the final roller will cut and shape the plastic bag. So instead of throwing plastic bags into the environment or burning them, through a recycling process we have a new plastic bag, which helps protect the environment and create many jobs for workers. However, in our opinion, plastic bags should only be recycled with modern processes because, as mentioned in the video, if old technology is used for recycling, the risk of recycling to the health of the workers working in the factory or people in the surrounding area will be seriously affected. Let's recycle according to modern processes for a green life. Thank you for watching the video and spreading meaningful things with us to help protect the earth, protect the lives of ourselves and our children. If you find this video good and meaningful, please give us one like, one share, leave a comment on your thoughts, and don't forget to follow the channel to watch more meaningful videos. Thanks and see you again.